Hi everybody, my name is Joey and I'm the Perfect Score Tutor. I've gotten perfect scores on both the SAT and ACT. However, I'm here today with a copy of the 2024 free response questions to the Calculus AB exam. I'll be breaking down the free response questions into detail so you can predict how you did on this exam. Or if you're looking at this from a future test date, you can use this walkthrough to study for your upcoming calc exam. So question 1 says the temperature of coffee in a cup at time t minutes is modeled by a decreasing differentiable function c, where c is measured in degrees Celsius. For t between 0 and 12, selected values of c are given in the table shown. And part A asks you to approximate c prime of 5 using the average rate of change over the interval 3 to 7. It says show your work and include units of measure. So to properly show your work, here's what I do. C prime of 5, and then since it's an approximation, I'm going to use the squiggles. C of 7 minus C of 3 over 7 minus 3. And then I'm going to plug in units from my table, so I get 69 minus 85 over 7 minus 3. 69 minus 85 is equal to negative 16, and then 7 minus 3 is 4. Remember, you don't have to simplify if you don't want to, but this is just equal to negative 4. And then units, since it's a rate of change, it's going to be the y unit over the x unit, so it's going to be degrees Celsius per minute. So part B says use a left Riemann sum with the 3 subintervals indicated by the data in the table to approximate the value of the integral from 0 to 12 of c of t dt. So to show my work, I'm going to rewrite the integral symbol. And then since it's an approximation, I'm going to do the squiggly lines. And then a left Riemann sum is the width of the x, or the t interval here, times the left y value. So the width is 3, and then the y value is 100. And then I'm going to plug in the next width. The next width is 7 minus 3, or aka 4. And then the left height is 85. And then the final width is 12 minus 7, which is 5. And then the height is going to be 69. Now, if this is hard for you to visualize, then you can also just kind of do a rough sketch of what the points might look like, right? So 0 would be 100, 3 would be 85, 7 would be 69, and then 12 would be 55. And then if we want Riemann sum, right, we just want rectangles. So you can visually see what the rectangles might look like, right? So this 100 corresponds to the height of this rectangle, this 85 corresponds to the height of this middle rectangle, and the 69 corresponds to the height of this small rectangle, and then all the widths here, right? So this would be 3 minus 0, this would be 7 minus 3, and this would be 12 minus 7. So drawing this actually could be considered showing your work as well, because then that would correspond to your answer. And let me go ahead and plug in what this is going to be on my calculator. And then that gives me 985. And then since I'm doing a Riemann sum, it's always going to be the y value times the x value in this case. So this is the units of degrees Celsius times a minute. Fortunately here, the unit here is not very intuitive and doesn't make sense, so they're not asking you for the unit, but if you ever wanted the unit, it's just the y unit times the x unit. And then if we're interpreting the meaning of 1/12 of the integral, this is just the average value. So we approximated the average y value. So 985 divided by 12 is the average temperature from time t equals 0 to time t equals 12. So in order for you to get full credit for this question, you probably want to say average temperature, and then you also want to remember to include the time values, because if you just say average temperature without referencing time value, that's not within the context of this question. Part C says for time t is between 12 and 20, the rate of change of the temperature is modeled by this function, where C prime is measured in degrees Celsius per minute, and they want you to find the temperature of the coffee at time t equals 20, and then show the setup for your calculations. So if we want to find the temperature from 20 degrees, we're going to take the integral from 12 to 20 of c prime of t dt. And remember that the integral from 12 to 20 represents the overall change in temperature, or if we use the fundamental theorem of calculus, that would be C of 20 minus C of 12. So basically, we're going to find our integral, but we're going to need to add the C of 12 over after we've done that. So I've gone ahead and plugged the function into my y1 here, and so then I'm going to quit, and I'm going to go to math, fn int. I'm going to integrate from 12 to 20 of vars, y-vars functions, and it's my y1 function. So this gives me the value of the integral, so negative 14.671. And then I'm going to add the C12 over to get C of 20. So what's C of 12? C of 12 is 55, so it'd be negative 14.671 plus 55 is equal to C of 20. So I'm going to take my number and add 55 to it, and then I get 40.329. And then let's not forget units, right? So the units would be degrees Celsius is equal to C of 20. So part D says for the model defined in part C, it can be shown that C double prime is equal to this function. For T is between 12 and 20, determine whether the temperature of the coffee is changing at a decreasing rate or an increasing rate. So notice how it said the temperature is changing. So the change of temperature is the first derivative, but then it says a decreasing rate or an increasing rate. So this is referring to the second derivative. A decreasing rate would be C double prime is less than 0, and an increasing rate would be C double prime is greater than 0. So then what we want to do is we want to go to our calculator. So I've already put my function in. I'm going to turn this top function off so I don't have to graph it. Now I want my window to be between 12 and 20 because that's what I care about. And then I don't know what I want my y values to probably be around 100 or higher because those are the values in the table. So I'll make my y max 100, and let's see if I got a good graph. Oh, interesting. So I think 100 was too big. So I'm going to clear this and make it 10, and let's see. I'm getting closer. That's interesting. It's really hard to see this graph, so I'm going to zoom in a little bit more. And there you go. So I see that my second derivative is positive this whole time. I was zooming in to see if it was increasing or decreasing, but I don't need to because I just want my second derivative. And I guess we could have just looked at it from the function as well, right? So if we look at it from the function, this part of the function is always going to be positive. For t is between 12 and 20, this is also going to be positive, and then anything on the bottom squared is always positive as well. So I actually didn't need to graph this question. So let's go ahead and write a reason for this answer. Because c double prime of t is positive for all values of t between 12 and 20, the temperature of the coffee is changing at an increasing rate. So for you to get full credit for this question, I think you need to reference that the second derivative is positive for specific t values, okay? It's not true for all t values, because if t is greater than 100, your second derivative becomes negative. But basically writing that out in a complete sentence would get you full credit here. All right, let's do some points predictions here. Typically on this type of question, I usually see it's worth 1 or 2 points. If it would be worth 2 points, you'd get a point for setting up the difference quotient here. And then you'd get another point for the correct answer with the units, okay? So no units, no credit for that part, but at least 1 point for there. Part B, okay, so this one is usually worth 3 points. So you'd get probably a point for showing that you know how to take a left Riemann sum. You'd probably get a point for the correct answer over here. The units, I don't think they're going to count in this part of the question. And then you get another point for the correct explanation of average temperature. Part C, they want you to calculate the temperature of the coffee at C is equal to 20. So you'd probably get a point for calculating the correct integral value, and then you'd get another point for including your starting value. Depending on the test, you may or may not get another point for the final correct answer too. And then part D, D is just asking you for an explanation. So This is interesting. So in part C could be worth 2 or 3 points. If it's worth 2 points, then this one would be worth 2 points. And then if part C was worth 3 points, then this question would be worth 1 point. So since this is a slightly easier test in my opinion, my prediction is that this one would be worth 2 points because I feel like most kids would be able to get A, B, and C, or at least get most of the points there. Thanks so much for watching this video. If something was unclear or you need me to break down an explanation even more, feel free to leave a question or comment below.